Hello, fellas. This is me, Aryan Kumar, and today we are going to study another crucial topic that is all about limiting reactant. Now, what is a limiting reactant? That might be a question, but before that, I'd like to clear that what is a reactant and product reaction. Any chemical equation, whereas we have a product that initially gives us a reactant, is known as a chemical equation. You know this. Okay. Now, what is a limiting reactant? Now you may see reagent at a lot of places at a lot of examples. Don't get confused. This is also a correct way to say it. Don't get confused. Okay. So reagent. What is a reagent or reactant? Limiting reactant. First of all, let's just consider any natural example, such as there are four four tires in a car. Okay, four tires in a car and one body. Okay, that is a constant value that every human being will consider if they are asked how much tires and what other accessories are in a car. Okay, in a car. Now, what if I give you a equation or number which says you only have 100 tires and 100 bodies? Now, just calculate it quickly. I believe that's the 75% less than it. That will be 25 at very main glance. Okay, so only 25 bodies will be able to utilize itself because there were limited tires. There were limited tires. That's why the bodies couldn't be used at their most. Okay, at their most number, that was 100. They were only utilized 25% of it. 25 bodies of it. Yes. So that is what a natural example seems to be. You can even consider an example of 16 bread slices and 16 kebabs. You will be only able to utilize 8 of them and other 8 will be still in count. Well, this was just an example. Now, how to calculate a limiting reactant? That is our main strategy today that we have to understand. Now, that is pretty basic. First of all, whatever you do here, as you learned in mass reaction, mass volume reaction, mole mass reaction, mass mole reaction, everything mole reaction, everything can be applied here according to the question. Now, okay, let me just give you an situation whereas we can utilize this thing and study it more perfectly. Now, C2H4 ethene, if you know, if you have studied this in your metric grade. Okay, sorry. Let me just again do it. Uh, yeah, so I'll just give or keep example as this. This is my book's example. That is pretty basic. That's why I considered it. Okay, 2CO2, 2 carbon dioxide, 2 exponents of carbon dioxide. Similarly, 2H2O. Now, whatever you get after seeing this equation, now the question asked is combustion of ethene and air to form CO2 and H2O is given in the equation. Okay, like CO2 and H2O combustion is given. You can see that combustion. Okay, 2 moles, or you can say 2 exponents per terminology. Okay, now the given masses of ethene, that is 2.8. Okay, and O2, that is 6.4. The thing I'll immediately do here is divide them by their molar masses. Now, if you can recognize this equation, that is like number of moles equals to given mass upon molar mass, and that is equals to the number of the moles that I need. Now, probably if I calculate that like 2 to 0 and okay, like again 1. 1, okay, 0.1. That is perhaps 0.1. Again, I have just calculated it by my mental maths. That is 0.1. And similarly, on the other hand, if I divide that by its molar mass, we can just simply say it as 2 multiplied by 16, and the whole equation again multiplied by 3. That gives me 32. Okay, sorry, it will not get multiplied by 3 because we will utilize it later. So the 32 number. Okay, now you can simply do one thing. You can just multiply it. Okay, like 3 1 the 3, again 6, 2 1 the 2, 2 2 the 4, and that gives me 0.2 moles of it. Now, I hope that you get it very correctly, very efficiently, that how this is being calculated. Now, to solve this problem, you first convert the given masses of both reactant into their moles, as we just did. Now, to find whether C2H4 or O2 is consumed earlier, like now I have to just guess, not guess, of course, we have to calculate which one is being utilized at first of their equations. Now, how to do that? Okay, the simple thing I'll do here is, okay, um, compare them. Okay, now first of all, compare it by CO2. Okay, then compare O2 by CO2, as it's asking, as the question asks us. So C2H4, 1 mole of 1 mole of C2H4 gives me 2 moles of C2 CO2. Okay, that will be like 0.1 moles of it gives me 0.2 moles of it, right? As the equation said here. Okay, I just proved that for you. Okay, so that is how we limit this till the number 2. Okay, and similarly, on the other hand, O2, that gives me CO2, and that goes like, according to the balanced chemical equation, 3 moles of O2. Okay, 3 moles of O2 give 2 mole of um, CO2, carbon dioxide. Okay, now what will I do is just multiply them by their moles. Okay, like 2 upon 3 for my absolute value, multiply them by 2, 0.2 moles, and I'll have my answer as 0.133 moles. Now you can just recognize which one value is less than its actual point. I can just simply say that since the number of moles of carbon dioxide produced by O2 is less, therefore oxygen is limiting reactant. Now our oxygen is limiting reactant here because it produces only 0.133 moles of CO2, carbon dioxide, and similarly on the other hand I get 0.2. That is of course a greater value. That is it for today's video. I hope you liked it. This was all about limiting reactant. Okay, you can call it as LR, and again this is known as limiting reagent as well. And similarly they can ask you a lot of questions such as give me volume at STP of any condition, or you will just simply when you are calculating moles, calculate moles, then multiply it by 222.4, and then have your answer, then compare the moles, then do the procedures of calculations, and similarly just compare them at the end, which value is more less than the actual value, and of course the one that is less is my limiting reactant because it ends at first. Thank you.